It is incredibly easy today to click a button and have your personal apps, side projects, and databases spun up on massive servers hundreds of miles away. Right now, giants like AWS, Azure, and Google Cloud are locked in a battle for market share, trying to absorb as much of the world's data as possible into their facilities. But running these sprawling facilities takes enormous amounts of power, hardware, and cooling. As those baseline operational costs climb, the providers pass the expense directly down to the users. That frictionless, easy deployment masks a hard reality. We have largely stopped owning our infrastructure, and instead we've all agreed to pay monthly rent for our own data. The initial bill always looks harmless, but as your data grows, you get hit with complex storage tiers and rising egress fees, which are charges simply for moving your own files around. You end up paying a recurring monthly fee to host a private finance dashboard or a half-finished coding experiment that sits there accumulating charges forever. At a certain point, you have to look at that recurring bill and ask, what if I stop paying rent? What if I take the data out of the cloud and put it on a physical machine sitting on my desk? Upgrading to a premium privacy tier on a cloud provider doesn't solve the dependency. To get true data sovereignty, you need hardware you can physically touch, control, and literally unplug from the wall if you want to. That brings us to the physical hardware, specifically the Raspberry Pi 5. It is a fully functional server that fits in the palm of your hand. You can build a 3-node hardware cluster for a one-time cost of about $600, bypassing the endless monthly subscription model. That initial hardware investment pays for itself in about 6 months. Every month of runtime after that is free. These devices do have strict limits. Having only 8 GB of RAM and mobile-style ARM processors means you can't run bloated software. Instead, you have to actively check your container images and understand exactly what is happening under the hood. In the cloud, you solve performance problems by paying to scale up. Here, physical constraints force you to optimize your code, which is the necessary first step to actually mastering your technology stack. But having 3 small computers on a desk isn't enough on its own. You have to figure out how to coordinate them so they act together as a single, highly available network. The industry standard tool for this is Kubernetes. The problem is that full upstream Kubernetes has massive dependencies and is far too heavy to run efficiently on low-power devices. The solution is K3s. It's a highly stripped-down distribution of Kubernetes, engineered specifically for resource-constrained environments. K3s removes the heavy enterprise bloat. It installs as a single binary with built-in networking, so you can start deploying immediately. Crucially, it is fully certified. The concepts are identical, meaning these skills directly apply to massive enterprise systems. That specific piece of software is the bridge. It transforms a hobbyist toy computer into a legitimate, production-ready server capable of severing your ties with the cloud. The end result is a highly resilient, private home lab. You can run personal finance dashboards, build your own private documentation servers, and host local AI assistants, completely off the grid. But you are making a harsh trade-off. You are permanently giving up the luxury of pressing a button for infinite scaling. You have to handle your own database storage, set up your own backups, and forfeit 24/7 managed support. When the server crashes in the middle of the night and DNS stops resolving, there is no IT department to call. You are the sole line of defense. In exchange for that intense burden, you gain absolute data privacy and entirely predictable costs. You also gain the ability to build and deploy strange experiments without ever checking a corporate terms of service agreement. A sanitized cloud tutorial gives you perfect isolated scenarios with known solutions. Fighting through the localized friction of real hardware failures builds a deep, battle-tested mastery of systems architecture. True ownership of your digital life demands a heavy, continuous responsibility. But if you are willing to take that on, it is the only path to absolute technical freedom.